Now we are going through exponential and logarithmic functions. Okay, so here we will learn to find the derivatives of exponential and logarithmic functions. Before that, let's know what is the exponential and logarithmic functions and its properties. So here, what is an exponential function? A function f of x is equal to b raised to x. A function of the form f of x is equal to b raised to x, here b greater than 1. Okay, this function is called exponential function with base b. Here b is always greater than 1. Okay, this function is called exponential function with base b. If b is equal to 10, then function is f of x is equal to 10 raised to x. This type of function is called common exponential function. Okay, common exponential function. If the base is 10, then the function is common exponential function. And the function f of x is equal to e raised to x. This function is called natural exponential function with base e. Okay, that is f of x is equal to e raised to x is natural exponential function. And here its domain is nothing but set of all real numbers, that is R. Okay, set of all real numbers, and its range is always positive, that is positive real numbers, that is nothing but open interval 0 to infinity. Okay, its range is 0 to infinity and its domain is R. That is why, see, its graph is like, if it is f of x is equal to e raised to x, then it's all the points in y-axis, it lies in only positive y-axis. Okay, and if it is x is equal to minus, if it is e raised to minus x, then it will be like this. Okay, so remember, its domain, exponential function, the domain of exponential function is set of real numbers, and the range of exponential function is a set of all positive real numbers, that is 0 to infinity. Okay, then next is logarithm. Okay, if a is a positive number, okay, and b is greater than 1, then a is equal to b raised to x. Okay, a is equal to b raised to x. Here this x is called logarithm of a to the base to the base b. Okay, this x is called logarithm of a to the base b. Okay, a is equal to, if a is equal to b raised to x, here b is greater than 1 and a is a positive real number, then x is called the logarithm of a to the base b. For let's take an example with numbers. Okay, we know that 25 is equal to 5 square. Okay, so here this can be expressed in logarithm as 2 is equal to log 25 to the base 5. Okay, that is 2 is equal to, 2 is the power, right? So 2 is equal to log 25 to the base 5. Okay, for example, here 4 square is equal to 16, right? So this can be also expressed in logarithm as 2 is equal to log 16 to the base 4. Okay, okay, now let's go through some important properties of logarithm. Okay, now let's study certain properties of logarithm. See, first one, log x to the base a is equal to log x to the base b divided by log a to the base b. Okay, log x to the base a is equal to log x to the base b, that is divided by log a to the base b. Okay, so here next one, log xy, here changing the base. Okay, next is log xy, that is product of two variables, log xy to the base b is equal to log x plus log y. See here, whatever the base is, log xy is equal to log x plus log y. Okay, log xy is equal to log x plus log y. And here third one, log x raised to n. Log x raised to n is equal to n log x. Here also the base is whatever. Okay, but the log x raised to n is equal to n log x. Okay, see if log 5 square, that is equal to, that can be written as 2 log 5. Okay, next log x by y. Here also the base is whatever. See, log x by y is equal to log x minus log y. Log x divided by y is equal to log x minus log y. Next theorem, dy dx of e raised to x is equal to e raised to x. That is, derivative of e raised to x with respect to x is e raised to x itself. So here we have to prove this one. Okay, before that, some results are here. You have to note this down. Very important. Log 1 is equal to 0. Log e to the base e is equal to 1. Log e raised to x to the base e is equal to x. Log 1 by x is equal to minus log x. E raised to log x is equal to x when x is greater than 0. Its proof is very easy. See here, we know that just we have learnt that how to express exponential form to logarithmic form, right? See here, you just write this logarithmic form to exponential form. Log 1 to the base b is equal to 0. We know that b raised to 0 is equal to 1, right? So here, how can we express this exponential form in logarithmic form? That is b raised to 0, that is 0 is equal to log 1 to the base b, right? Next to this one, log e to the base e is equal to 1. Here e raised to 1 is equal to e, right? Okay, see how to write this in logarithmic form. 1 is equal to log e to the base e. Okay, log e to the base e, right? So next is log e raised to x to the base e is equal to x. That is e raised to x is equal to e raised to x, right? E raised to x is equal to e raised to x itself, right? So here we can write x is equal to log e raised to x to the base e, right? X is equal to log e raised to x to the base e. Okay, just here we can express, we have learned that how to express the logarithmic, that is related, right? Logarithmic function and exponential function. So, and we know that how to express this logarithmic to exponential, exponential to logarithm, okay? So, these results are nothing but it is the exponential form, okay? So, log 1 by x, applied the properties of the logarithmic function. That is log 1 by x is equal to log 1 divided by x is nothing but log 1 minus log x, right? So what is log 1? Log 1 is 0. Okay. So log 1 is 0. So the answer is minus log x. So log 1 by x is nothing but minus log x. Okay. Because log 1 by x, we have these property of logarithmic function, log x by y is equal to log x minus log y, right? So log 1 by x is equal to log 1 minus log x. Log 1 is 0, therefore it is minus log x. And e raised to log x is equal to x. Okay. So here also we can write this in, first we will write this in logarithmic function, logarithmic expression, that is log x is equal to log x base e, right? That is same thing, right? Log x is equal to log x base e, that is log x is equal to log x. So when x is greater than 0, see why x is always greater than 0 here? Here in logarithmic function, its domain is all positive real numbers. Okay, here domain of logarithmic function is positive real numbers. Okay, then now let's prove this one. Derivative of e raised to x is equal to e raised to x. See here you have to note this down, very important. Then e raised to x is equal to e raised to x. So here first of all let's prove this function e raised to x, a derivative of e raised to x exists and what is its derivative. Okay, let's find by the definition of the derivative of function, right? We know that f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Okay. We learned that if a function derivative at c, at x is equal to c, then here in place of x we wrote x is equal to c, right? F of c plus h minus f of c divided by h. But here we have to prove this function, the derivative of this function exists at all the points. Okay, so here we taking x itself. Okay, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Then here first of all we have to prove this derivative means f dash of x exists, right? Okay, so limit h tends to 0. Limit h tends to 0. What is our function? Our function is e raised to x. Okay, f of x is equal to e raised to x. It is our function. Okay, then what is f of x plus h? F of x is equal to e raised to x. Then what is f of x plus h? E raised to x plus h. It's very important. It's proof. Okay, derivative of e raised to x is equal to e raised to x. Okay, you may be asked to find prove the derivative of e raised to x is equal to e raised to x. Okay, it is the proof. So limit h tends to 0, e raised to x plus h, because f of x plus h is equal to e raised to x plus h minus f of x. F of x is e raised to x divided by h. Okay, then here limit h tends to 0. This can be written as power rule. Okay, you have already studied in 8th or 9th standard power rule. That is e raised to x plus h is nothing but e raised to x into e raised to h, right? Okay, e raised to x into e raised to h minus e raised to x divided by h. Okay, it is equal to limit h tends to 0. Here in both terms e raised to x is common, so let's take it out from this bracket. Okay, so e raised to x into e raised to h minus 1 divided by h. Okay, so this can be written as limit h tends to 0 e raised to x into, because we know that limit of f of x into g of x is equal to limit f of x into limit g of x, right? So limit h tends to 0 e raised to x into limit h tends to 0 e raised to h minus 1 divided by h. Okay, see here limit h tends to 0 e raised to h minus 1 divided by h. See, we have studied this standard limit value in limits chapter. Okay, that is limit h tends to 0 e raised to h minus 1 divided by h. We have studied limit h tends to a tends to 0 or x tends to 0. Yes, limit x tends to 0 e raised to x minus 1 divided by x is nothing but 1. Okay, that is we have already studied in limits chapter in class 11. Okay, limit x tends to 0, I will write here, limit x tends to 0 e raised to x minus 1 divided by x, that is equal to 1. Okay, so its limit is 1, and here limit h tends to 0, here there is no h, right? So the value is, limit value is e raised to x itself. Okay, so here e raised to x into 1, this value is 1, so it is equal to e raised to x. It is the proof. Okay, proof of derivative of e raised to x is equal to e raised to x. Next theorem is d by dx of log x is equal to 1 by x. That is derivative of log x with respect to x is 1 by x. Let's prove this. So function is f of x is equal to log x, right? So here we have to prove f dash of x is equal to 1 by x. Okay, now let's define, take the definition of the derivative of the function. F dash of x is equal to limit h tends to 0 f of x plus h minus f of x divided by h, right? That is equal to limit h tends to 0. What is f of x plus h? F of x plus h is, f of x is log x, so f of x plus h is log x plus h minus What is f of x? Log x divided by h. Okay, by our property, one property, that is log of x by y is equal to log x minus log y. Okay, we have a property of logarithm. Log of x by y is equal to log x minus log y. So this log x plus h minus log x can be written as log x plus h divided by x, right? Because log x minus log y is equal to log x divided by y, right? So here in place of x, x plus h, in place of y, y, x, right? So this can be written as limit h tends to 0 log x plus h divided by x divided by h, right? Here log base e, okay? Log base e. That is the natural logarithm, okay? So log x plus h divided by x divided by h. Then let's simplify. Limit h tends to 0 log base e. X by x is 1, okay? Split it. X by x 1 plus h by x. 1 plus h divided by x divided by h. Okay. Then here, then let's multiply and divide it by 1 by x. Why? Because say we have a limit, standard limit, limit x tends to 0 log 1 plus x divided by x, that is equal to 1. Okay, we have a standard limit, limit x tends to 0. This also we studied in our limits chapter in class 11. Okay, limit x tends to 0 log 1 plus x divided by x is equal to 1. So let's make it in the form of log 1 plus x divided by x. Here log 1 plus h by x, right? So here denominator should be h by x. So for that, here we have to multiply 1 by x in denominator. Then we have to multiply 1 by x in numerator, right? So here that is limit h tends to 0 log 1 plus h by x, okay, divided by h by x. Here we have multiplied 1 by x in denominator and next multiply 1 by x in numerator, right, into 1 by x. Okay, now it is correct, right? So limit h tends to 0 log 1 plus h by x base e divided by h by x. Now it is of the form this one, right? It is in the form of this limit x tends to 0 log 1 plus x divided by x, so that we can apply that limit value 1, right? So here, and it is 1 by x, there is no h value, so we can write it directly. That is limit h tends to 0, 1 by x is nothing but 1 by x itself, right? So 1 by x into this limit is nothing but 1. That is limit h tends to 0, 1 by e. Here if h tends to 0 means h by x also tends to 0, right? Okay, so 1 log e 1 plus h by x divided by h by x is 1 into 1, that is equal to 1 by x. Therefore, f dash of x is equal to 1 by x. If f of x is equal to log x base e, then f dash of x is equal to 1 by x. That is derivative of log x is equal to 1 by x. Let's find the derivative of given some functions. Sin log x e raised to cos x. Okay. Here first one, f of x is equal to sin log x greater than 0. Okay. F of x is equal to sin log x. Here we have to find the derivative of this function. If y is equal to sin log x, then dy by dx, or f dash of x. F dash of x is equal to, here apply chain rule. Okay. So first we will find the derivative of sine, then log x. Okay. What is the derivative of sin x? Cos x, right? So cos log x into derivative of log x is nothing but 1 by x. Derivative of log x is 1 by x. Derivative of e raised to x is e raised to x. Okay. So cos log x is equal cos log x into 1 by x. That is cos of log x divided by x is the derivative of sin log x. Okay. Next, second one, e raised to cos x. F of x is equal to e raised to cos x. So f dash of x is equal to, here consider cos x as x. So if it is e raised to x, then what is the derivative? E raised to x, right? Derivative of e raised to x is e raised to x. So we will write e raised to cos x. Okay, you just consider cos x as x. Okay, just take cos x as x. So it will be e raised to x, right? Derivative of e raised to x is e raised to x. So e raised to cos x is nothing but e raised to cos x into derivative of cos x. Okay, derivative of cos x is minus sin x. Okay, therefore minus sin x e raised to cos x is the derivative of e raised to cos x. Okay, so first we will take the derivative of this one, that is e raised to x, then derivative of cos x. Okay,